Building a linear regression calculation using MDX and a Microsoft Analysis Services OLAP cube and extending the results into the future for the purpose of multidimensional forecasting can leverage vast amounts of data to analyze the past and predict the future with agility, flexibility, and scalability. Today I will walk you through an example of how linear regression and forecasting analyses can be built using simple MDX within a traditional Kimball-style star schema. I'm Greg Beaumont and I work for GNet Group, a gold-certified Microsoft Business Intelligence partner. Learn more about GNet Group at gnetgroup.com or blog.gnetgroup.com. You can follow GNet Group's Twitter account at GNet Group and follow my Twitter account, which is at grbeaumont. Here's the agenda for a walkthrough of the process by which to build regression lines and forecasting calculations into a Microsoft Analysis Services OLAP cube. We'll start by reviewing the concept of a linear regression. Next, we'll discuss the benefits of using an OLAP cube. Then we'll review the elements required in an SSAS OLAP cube to add regression lines and forecasting. We'll walk through the MDX calculations that need to be added to the cube. And finally, we will review how these calculations can be used in a front-end tool. Here's a standard line graph with values on the y-axis plotted over integer values on the x-axis. A regression line is effectively the trend line for this graph. A linear regression line can be defined with the equation y equals ax plus b. So if you look at a specific point on the regression line, x is the value on the x-axis. Not surprisingly, y is the value on the y-axis for the same point on the regression line. If you extend the regression line to where x equals 0, b is the value of y at that point. It is also referred to as the y-intercept. As for a, take the rise from b to y and divide it by the run from 0 to x on the x-axis. Rise over run gives you the slope of the linear regression line. So why do a linear regression in an OLAP solution? OLAP cubes are designed to crunch millions, if not billions, of rows of data for optimal reporting performance. Your environment, the resources dedicated to that environment, and your data will determine the scalability and limitations of the OLAP solution that you can build. Also, multidimensional query capabilities open up nearly limitless possibilities for combinations of dimensional data. Additionally, many organizations across the globe have Microsoft Analysis Services OLAP cubes in their existing business intelligence environments. So what if a company requires separate 12-month regression lines for 606 unique products, 16 unique promotions, and 11 unique sales territories? Multiplication tells us that would be 106,656 different regression charts. So if it takes 5 minutes for an analyst to download each data set and create each chart, then it would take one analyst 4.4 years to complete. To take it even further, with an OLAP regression in Microsoft Analysis Services, multi-select capabilities allow for countless combinations for which a regression line can be generated. For example, a dimension with 3 granular members can have 7 different multi-select combinations. You can select just 1 member, 2 members, or all 3 members. What about for 606 unique products, 16 unique promotions, and 11 unique sales territories when you're multi-selecting? That's 3 times 10 to the 190th power regression combinations. That's greater than a vigintillion possibilities. Let's move on to the design of the cube in Analysis Services. Here's a simple cube I built using AdventureWorks data. Notice the measures from the date dimension. The measure month key has the aggregate function set to max and the properties window in the bottom right-hand side of the screen. Looking at some sample columns and rows from the date dimension, you'll see that month key is an integer that consists of concatenated year and month numbers of year values. With an aggregate function of max, this set of rows would evaluate to 201304. That's 2013-04. You'll see where this fits into the regression shortly. The measure of completed days assigns a value of 1 to days that have already happened from a data warehouse perspective. Summing up these days gives you the number of completed days in a set of rows. We'll use these two measures along with the measure for sales amount for the regression. We'll also use the sales territory, promotion, and product dimensions. Let's review the calculations that lead up to the linear regression and forecasting capabilities. Rank 12 months is a calculation that will yield the value for x in the regression equation y equals ax plus b. Looking at the sample rows from a date table, The x-axis for a regression line will be the rank of the months in the set of rows. The MDX for rank 12 months starts with a static set of the last 12 completed reporting months, ordered by month key, and then a rank value is given to the current member based upon that month key. In the sample example, December 2012 will evaluate to 1, and April 2013 will be 5. The next calculation, 12-month trend, finds the y value from the linear regression equation. For whatever value of x that you are observing, y is the corresponding y value on the axis. The MDX code for 12-month trend uses the expression linreg point to evaluate the y-intercept at a given value x over the rolling 12 completed months with respect to the statistical relationship between sales dollars and the sequential progression of months. It is wrapped in an if statement so that when on a graph, it will only be displayed for completed months. Having that calculation in the OLAP cube, we can now graph linear regression lines for multidimensional sales data. Using Excel 2013 to connect to the OLAP cube for a pivot chart, you can see that sales amount has a trend line, which is our MDX calculation that we built, 12-month trend. And not only do we have a linear regression line built with MDX, but it is fully slice and dice ready for dimensions hooked up to the sales fact table. Multi-select is also a possibility for all of the dimensions that are hooked up to this fact table. Before we move on to forecasting, please note that the process to create OLAP regression lines using MDX can be reviewed at the GNet Group blog. Now let's extend the linear regression line into the future so that future sales can be calculated and visualized. First, we will need to add some more MDX to the cube. 12-month slope will be a calculation to evaluate the slope of the regression line, or the rise divided by the run. The MDX will take the rolling 12 months, sales amount for the y-axis, and rank 12 months for the x-axis to determine this value. Projection 12-month count is a calculation that will determine how many months in the future or how many months from the last month with data a particular month is. So logically, you can think of projection 12-month count as a future month rank of the months that have not happened yet from the perspective of which months have completed days. So let's replicate that logic with an MDX expression. Count the months requiring predicted values from the last month with completed data to the current month being evaluated. Since the last month with data is included in the count, subtract 1 from the number. Let's move on to the final MDX calculation in this solution. So finally, the calculation projected sales 12-month will extend the regression line from the last 12 months with data as a forecast into the future. The trend line value from the last month with data will be used as a starting point, and the slope of the regression line multiplied by the metric projection 12-month count will be added to it. Then an if statement will be used to ensure that the expression is only evaluated for months in the future. Before we take a look at how these projections graph out, a recap of these linear regression forecasting calculations can be found in another article at the GNet Group blog. Now let's plot the OLAP forecasting data on a pivot chart. We'll use Excel 2013, keeping in mind that Performance Point, Reporting Services, or any other front-end tool that displays Analysis Services OLAP data can in fact display these calculations from the cube. Do these dimensions look familiar? Product, promotion, and sales hierarchy are the dimensions which were referenced earlier when discussing the countless possibilities that you can have when combining data using OLAP multi-select. Looking at the product slicer, you can add to the dataset for Mountain 200 Black 46, the Mountain 200 Silver 38, and then you will get both of those products combined. Within the promotion slicer, you can select volume discount 11 to 14, and then you will have a filtered data set for those two products. Looking at the chart itself, you'll see that you have the actual sales numbers, which are the blue line. You have the regression line for the last 12 months of data, which is the orange line. And now we also have the projected 12 months of data in the future, which is the silver line. That is the MDX calculation that we created, projected sales 12 month. What's nice about the forecasting calculations is that you're not limited to just one line. Looking at this chart, you'll see that we have the 12-month projected sales that we had on the previous example, but we've also added 6-month projected sales. So it's taking the regression line from the last 6 months of data and extending it 6 months into the future. Once again, multi-select is also a possibility, as it is with all of the other calculations in this OLAP solution. Once again, a recap of how to go about doing a regression line and a regression forecasting line can be found at the GNet Group blog, which is at blog.gnetgroup.com. If you'd like to learn more about GNet Group, a Microsoft Gold Certified Business Intelligence partner, you can either visit gnetgroup.com or contact us at sales@gnetgroup.com.